Hello everyone, today we're going to go over properties of gases, which is a subject in chemistry, so let's begin. So first, we need to look at compressibility. So unlike a solid or liquid, gas can expand to fill its container. Now this leaves a significant amount of empty space between the gas particles, and the volume of this empty space is significantly larger than the volume of all the gas particles combined. But this also means that that empty space can easily be compressed. But what is compressibility? So compressibility is a measure of how much the volume of matter decreases under a certain amount of pressure. Because the molecules are far apart, gases are easily compressed compared to something like a solid or liquid. Now, going to the model below, we see that gases can be easily compressed because of the spaces between gas particles, and as a result, the same amount of gas can fit into containers of many different sizes. As you can see in this little picture, there's a large one and a small one, and in the smaller container, the same amount of particles are compressed in less volume. However, that volume is still mostly empty space. So, larger container and the same amount of particles in both, but both of them still are mostly empty space. So, continuing, let's look at gas pressure and amount of gas. So, kinetic theory can be used to predict how a gas will respond to a change in its conditions. Adding more gas particles to a container does not affect volume, but it will affect the pressure. So gas particles are in constant motion, and adding more particles will increase the gas pressure. So to sum it up nicely, more particles equals more collisions, and more collisions equals more pressure. So looking at the model in the bottom left, when you add gas to a container, such as pumping gas into a closed container which has a fixed volume, pressure will increase as more particles are added. So as you can see, there's 100 kPa in this one, and it has a few particles, but when you add more particles, the pressure increases. The higher pressure leads to more collisions of particles with the walls of the container and with one another. If the pressure gets high enough, the container may even rupture. So here you can see there's 600 kPa and there's so many particles, and the container just breaks open. And another example is pumping air into a tire. So air pumps increase tire pressure by moving outside air, which is gas particles, into the tire. When you pull up on the handle, a one-way valve opens and allows outside air to flow into the chamber. And then when you press down on the handle, the top one-way valve closes while the bottom one opens, and the piston pushes the air into the chamber of the tire, as you can see right here. So here you're opening it up and letting air go in, and then you're pushing down and pushing that air into the tire. So now let's look at gas pressure and how it relates to volume. So gas pressure increases when volume decreases. When gas compresses into smaller amounts of space, the particles are forced closer together. This closeness increases collisions, resulting in increased pressure. So basically, more compression means a lower volume, and that equals a higher pressure. And here's an example. Pressing down on a piston requires someone or something to push. This push is equivalent to the pressure inside of the cylinder. You have to push down harder to make the volume smaller because there's so much pressure in the container. And going to the model, and this is similar to the example, but as you push down on the handle, you decrease the volume of the cylinder containing gas, resulting in an increase of gas pressure. The higher pressure makes it harder to keep reducing the volume, which is you pushing down on the handle. So when the piston on the top is not moving, the pressure of the gas pushing up on the top is equal to the pressure from the piston top pushing down on the gas. And when you push down and decrease the volume of the fixed amount of gas, that leads to more collisions between the gas particles, as well as between the gas particles and the inside wall of the container, which increases the pressure, making it harder to continue pushing down. So the pressure basically is equivalent inside the container and when you're pushing down on the container. So now let's do a practice problem. So the question is, how does the pressure change of a fixed amount of gas at a constant temperature if the volume of the gas triples? So the first option is the pressure will triple. The second option is there's no change. And the third option is the pressure is reduced to 1/3 of the original pressure. So I'll give you about 15 seconds or so to do this problem. And if you picked the pressure is reduced to 1/3 of the original pressure, then you would be right, because remember, pressure and temperature, or not temperature, but pressure and volume are basically opposites. You increase the pressure, you decrease the volume. You increase the volume, you decrease the pressure. So the pressure will be reduced to 1/3 of the original because the volume is tripling. And here's the next problem. How does the volume change of a fixed amount of gas at a constant temperature if the pressure of the gas doubles? So there is no change, the volume will double, or the volume will reduce to 1/2 of the original volume. So I'll give you another 15 seconds. So if you said the volume reduced to 1/2 of the original volume, then you would be correct. Because remember, when the pressure doubles, the volume will have the opposite effect, and in this case, it will halve. So now let's continue, and we're going to look at gas pressure and temperature. So temperature is the average kinetic energy of the particles of gas. Increasing the temperature will cause the particles to move faster because of that increased kinetic energy. And faster moving particles will increase the likelihood of and the force of a collision, resulting in pressure going up. So to give a small summary, more temperature equals more collisions, and more collisions equals more pressure. So as you can see in the little model, at constant volume, pressure and temperature are directly proportional. When temperature increases, pressure also increases due to the faster moving particles. And as you can see here in the first one, the temperature is pretty low and the pressure is 100. But when the temperature increases, the pressure goes to 200, so it almost doubles here. And you can see how the particles are moving faster now. And then here, if the increase in temperature causes the pressure to become high enough, the container may rupture. So here, the temperature more than doubles again, and the pressure goes all the way up to 500. And there's so much pressure that the container just ruptures. So now let's do another practice problem. So how would decreasing the temperature of gas molecules in a fixed volume container affect their kinetic energy? Would the kinetic energy increase, or would it decrease? So if you said that it would decrease, then you would be right. Because remember, temperature is kinetic energy. More temperature, more kinetic energy, and vice versa. And in this case, we're looking at it decreasing. And moving on to the next practice problem. This one has two answers actually, but let's see what it is. So the pressure volume, and temperature pressure relationships that exist within gases do not exist within liquids or solids. Identify two factors related to gas particles that allow for these relationships to exist in gases. So only gases are found in high temperatures, only gases exhibit pressures, gas particles can move from one point to another, or gas particles have a lot of space between them. So there are 4, and 2 of them are right. So I'll give you a few seconds to do this one. So if you said that gas particles can move from one point to another, and gases have a lot of space between the particles, then you would be correct. And that's the last problem I have for you today. Thank you for coming and watching this video about properties of gases, and there will definitely be more videos on the STEMEY channel. Thank you.